Thank you very much for the introduction. Also, thanks a lot to Sylvain for lending me his computer, because I have a new MacBook which does not work here, unfortunately. So, okay, this is a talk about deep learning for fun and profit with PyTorch. This is not a very technical talk. It's not technical at all. It's a little bit more about processes and what we can do. I think you have heard about this in the introduction. So I like organizing Python conferences. Obviously, I like to talk. I work at the boutique consultancy in Mannheim, which is south of Frankfurt. We are helping startups and also big enterprises on digitalization and data science. We also recently launched PyData Frankfurt as a meetup, so we're going to hear more about this tomorrow. The lightning talks. Okay, so the story so far. This is not the first time I am talked about this. The very first talk I gave about it was at PyData Berlin. It's also on YouTube. It was more like how I made my computer write his first story, and also talked about it at EuroPython. This is the next update on the topic, so I won't go deep into everything here. So the talk is basically moving on all the time, so if you want to catch up, go to YouTube and watch if you want to go deeper in some parts. I'll give you a short summary for the beginning. So my inspiration came actually from Gene Kogan. Gene Kogan spoke at PyData London, and Gene Kogan is an artist, and he uses AI for art. And I thought this was very inspiring because a few of you know, IT is my second career. My first career was in the music industry, running techno and house labels in the 90s. So I'm always drawn to something creative and creativity. So I thought this was really nice. So I thought, okay, let's get the eGPU box to build a local lab with my MacBook. So this is an example of an eGPU. You can have like an external graphic card in here, and with Thunderbolt, you can just like plug it in. It's nice. I just had the feeling to have a little nice lab on my Mac to do some experiments, but if I need more computation power, move them to the cloud eventually. It's not plug and play, as you might think. There's a lot of troubleshooting involved, especially with PyTorch and compiling PyTorch for CUDA with eGPUs, but there's a lot of help here on the side here, and there's some great guys who made some scripts to set up your computer to make it work. So the first story, I just had some time. I had my eGPU, and I thought, let's do some style transfer. Who heard about style transfer? Okay. Then let me give you a quick introduction. Style transfer is an algorithm from 2015 where you can learn a style from a picture, for example, like a Van Gogh picture, and apply it to a photograph. And then the photograph will look like as it was painted by Van Gogh. That's the idea. And it works quite simple. So I thought, okay, this looks nice. Let's grab some code and make it work. And I started with this. Because when I was a kid, I used to go to the public library and read these comics. Unfortunately, not in French, but in German. Yeah, but I really like the French 80s comic style. So I said, okay, let's go back, grab a comic here, and apply it to a modern DC comic, like The Flash. And this is what I did. So I had like this piece of the comic. This was what the model was trained on, and I applied it to this picture from Flash and Kid Flash, and this was basically the result. I said, oh, wow, this is super cool. I mean, this was like really easy. I just used some boilerplate code from the internet. Actually, it was not even optimized. I said, wow, this is like magic. So let's do this with holiday photos from Scotland. Or you can also take a painting from Henri Rousseau. Okay, this wow. I was very impressed. You can also use it for psychedelic pictures from Valérian and Veronique, as it is called in German, like Valérian and Lorelei. And you can apply it to Game of Thrones, the tiger, and wow, it was quite impressive. Also, You can also like use it for like a whole comic page. Here you see like another modern comic of Batman with the Flash, whatever they're up to, and transfer it into French style, the right style. So a nice finding on the way, and this is why I think working and playing around with neural nets is so important, because a nice finding on the way was I just thought, okay, what about a very old Flash comic from the 50s or 60s? And I only was able to get some very blurry scan from the internet. This is like the original size compared to this, so this is really hard to read. And just applying the style, it just not applied the style and refreshed colors. It was also readable again. So this was quite nice and could be also some use, which brings us to the profit section of this talk. But I have to tell you up front, like I had a lot of fun, but monetary profits is limited until now. So, okay. You can also, I also like trained on this picture from the same comic, and you can also like feed the models white noise to, and then you get a picture like this. And I said, oh, hey, I just like sent this via messenger to friends. I said, hey, I'm at Tate Modern. I really fancy this picture. How do you like it? I said, oh yeah, it's a great piece of art. So it's fun. It's a new way of doing things. Also for EuroPython, this is Edinburgh. EuroPython was in Edinburgh this year, and so this was like the picture we used for advertisement for EuroPython. It was quite famous with the old town, and I just tweeted it to announce my talk. So hey, later I'm going to talk about this, and somebody answered, and I assumed it was some attendee, and I said he just tweeted this picture, and I said, aha. Okay, this is reality that transfer then, because I thought he had some domain expertise. Obviously, it was just some random guy who saw this on Twitter, and he thought, oh, I took this picture a few days ago. I was wondering when you posted that drawing. And I said, it's not a drawing. It was generated by artificial intelligence. And then, okay, I see, even more amazing. You can have fun stuff. And of course, Python is a very good language, but you know, Python is just a lot of fun. And of course, what can you do? You can take like, this is just like a picture from the Eiffel Tower, and this is like 3 pictures I just grabbed sitting up there from a costume shop and put them in front. Because if you really like, you see it's actually somebody proposing here, but I put them in the back. And applying the style, you can make it like this, and you can have like the emperor, the PyParis, like here, like your own comic. And of course you can also like have the whole story how I traveled here. So of course I took the TGV, because another fun fact, from Mannheim to Paris with a TGV, it's only 3 hours. This is awesome. So I went to the metro, and here you see the metro and how it picks up the details, like yeah, thank you. I just copied some models, so yeah. So yeah, it's quite amazing what you can do. And here you see like the keynote in the morning, and so yeah. Another learning: training models takes time. Applying models is really fast, because you can just like I just put them on my computer, and as you see, people make really happy. Yeah, for PyCon, side note, for PyCon, I think the website from Anand is still up. After PyCon, we did a website where you can basically upload a picture, and you can have like the style transferred, because so many people asked for, can you make me like in a comic? Okay. So you can imagine, I see from your reactions like, oh, okay, this is like awesome, neural networks are the best, let's go deeper. So I developed in my head, okay, let's do a talk at PyData Berlin about it, and I had the following vision, because I felt like this, like, wow, awesome. So I thought, okay, let's take this further. How far can I push it? Because what I did before was basically, I read something about it, I was impressed, I found some nice and useful content on the internet and on GitHub, and I could build on that and make it happen with some efforts, but basically compared to the results, not so much effort. So I thought, why not go for this? This is something you most likely don't know. Maybe Wolf might know it. Yes, he knows. Okay, this is the 3 Fragezeichen, the 3 it's like 3 question marks. It's American detective stories. It's the 3 investigators, and the only country in the world where this is actually popular seems to be Germany. So it's books. It's like mystery detective stories of 3 teenagers. It's in California. There are 200 taped radio dramas, and I'm going to go into that as well, and books. And this is, they are accounted for 80% of the market, and the whole market for radio dramas is quite big in Germany, but this seems to also be like quite a German thing. So let me explain a little bit more about it, because I looked it up. There's not even a French word for this. So taped radio drama is the best for Hörspiel, as we call it. So, okay, Hörspiel. Let's go back in the days. Let's go pre-internet, pre-television. We're now in the 1920s, where people had just like radios, and people were listening on the radios to stories. And this is basically what a Hörspiel is. Hörspiel is a movie without the pictures. You have a narrator, you have voice recordings, noises, people, dialogues, talking. It's an art form. It's still on the radio in Germany. There's like a new Hörspiele coming out as well. And of course, also like the 3 investigators. And one of the most one of the most successful was actually by Orson Welles, also in the late 20s or 30s, I don't know exact date. Actually, it was like the War of the Worlds. I think everybody has heard about the War of the Worlds. Aliens are invading the world. And basically, this was actually a radio drama. And actually, the thing and the genius move from the young Orson Welles was, it was the first radio drama which sounded like a news show. So actually, it was doing like a live reportage. Yeah, aliens have now invaded this farm real life, and all this. And just like remember, back in the days, this was very new, and people were actually panicking. They thought this is real. They were listening to the radio and thought, okay, aliens are actually invading the States. Luckily, they didn't. So okay, so let's. Yeah.
Wie kann eine 3000 Jahre alte Mumie flüstern?
Er ist der Ahne des Hauses Hemmel. Vor 3000 Jahren kamen Könige aus Libyen nach Ägypten.
That's like basically the idea how it sounds like. Okay, and these are the covers. So let's check with the covers first. Okay, yeah, okay. Okay, let's see. Okay, these are like covers, so we also have to produce an artwork because it's live on Spotify or Deezer and iTunes. Okay, let's break down the problem, because the idea was here, how, not just I got overexcited and artificial intelligence can use everything, I wanted to turn it around. See, okay, we see neural networks being really good at solving very specific tasks, which are very impressive, but what if we turn it around and try to synthesize something simple as a children's radio drama with AI? So what do we need to do in general? The ingredients. It's a story and a plot. We need dialogues, dynamic human speech, the covers, and we need to also have spoken word by new and returning characters. This is basically the ingredients we need to try to synthesize. So this is how far we can get. So questions are, what are the resources? Because this is also a little bit an exploitation. What is actually the required? Where are the problems? How much time takes it? How much budget is necessary? And also always have an open mind for which future problems can potentially be solved with that. Okay, then let's move to the realization. Luckily, I found some transcripts from the text from the radio dramas because they were fan-made. So this was nice. And of course, I own all the recordings anyway. So, okay. Back to the process and the technology selection. We have a local app. Ability to scale to the crowd. This was covered in previous talks. An important part after the first experiment was actually here, and I cannot basically emphasize this enough, reproducibility and documentation of the experiments. So every parameter you feed in, like the random seed, the picture taken, the text use, document this, because my very first model I was not able to reproduce because I just threw some code in it. I didn't document anything, and I would not be able to reproduce the experiment or reproduce the model to optimize it maybe in another way. For further experiments, I built like a nice setup, so everything's documented. And I settled for PyTorch because it felt very accessible for me from the Python programming perspective. Okay, so the process here is always the same. Data acquisition, data cleansing, research a paper, working solution, verify this is actually working, adapt the solution for the use case, and maximize the quality. And always change only one variable at a time. So to really know what's happening and what's working and what's probably not working. So first thing, okay, since everything worked so well with the style transfer, what about text? Because who knows this blog post from Andrew Karpathy, The Unreasonable Effectiveness of Recurrent Neural Networks? Okay, to the rest of the 98%, I recommend read it. It's a very good blog post. Andrew Karpathy, this was during his PhD time, and he wrote a blog post on RNNs and how to, and in this blog post, one part he demonstrates how the network learned from Shakespeare to create new Shakespeare. And this was like impressively well. And I said, okay, so Shakespeare, the three investigators, the text corpus size are comparable, and the question now is, are they just enough to learn something? Because this is like medieval English. So let's try this in German. So we have some human-made text. I also was able to identify the characters with some other fan page, and the text corpus now I was working with was German language and 1.5 million words. 56,000 of them were unique, and we use an RNN for that. So the first step was take the Shakespeare corpus, produce something Shakespeare-y that worked well, and now we're feeding it with the German corpus. And this is basically what came out of it. It's impressive German, isn't it? Who speaks German? Okay. Who agrees this is great German? No, just like actually Google Translate was actually quite good in translating it into English. It's like a very good representation what you see here. So actually, probably for you, from the non-German speakers, this looks like German. It also contains some German words, but it also invents new words like Schlockoliana and Lust or Prux, which is not a word. So okay, it was really funny. You can also like send it to your friends, like something else, yeah. And then they just replied, "Are you talking Vong?" And Vong is like a youth language, which is basically invented by some comedian. And okay, and I said, no, it's not Vong. This is a neural net. Okay, the same. The third was character-based, so the idea of an RNN, to get a little bit is to take sequences, feed it into the network, and basically get the probabilities of which characters basically align with each other, and then predict new characters. And you can also do the same with words. Usually sequences are better to train because the matrices are smaller, because we only have to basically do it by character. With the words, the matrices are way bigger, and but it also like yeah, it was funny, but it was not really useful. So little bummer. So I said, okay, how else could I solve the problem? Because we hear a lot about chatbots, and I was really very excited to read about how somebody trained a neural net, like a great blog post about somebody trained a neural net on Star Trek: The Next Generation and launched bots on Twitter. So you can have like Captain Picard as bot Picard, and you can just tweet to him, and he will reply. And the idea was to make up a Star Wars Next Generation story plot. And then other people like Worf and Data, they also join. And I said, okay, let's try this because I'm looking into creating dialogues. But actually, this was also quite disappointing because it was just like a lot of noise, especially like it was just feeling they were battling all the time and leaving the bridge and explosions. So, and it took me like a week until this was over. So, okay. After all this excitement when the style transfer space, this was a little, okay. But when I looked at my bookshelf, okay, I wasn't surprised because all these problems are not very new. They are not new problems. They are actually old problems because if you look at the book covers here, you see this is not retro style books. They are really old. So neural networks are old. They're just like sleeping for a while. So okay, so it's not that easy. Okay, so let's move on. What's the next problem we could solve? Let's try to fabricate the artwork. For the artwork, I already told you about style transfer. It's using convolutional neural networks or short CNN, and then we basically learn an image represent the idea of the network here. Is basically learn the image representation. So here you have a very good representation, and basically here you have a quite rough representation of the image. And then you can take this image and basically reverse the whole process and basically reconstruct the style on this. This is like the very basic idea in 2 sentences. And this works well on many styles and pictures of Yosemite. And this works probably also right for 3 Fragezeichen covers. And half of them are fake. Usually when I talk in German, many people are say, oh, okay. Any guesses which one is a fake? Who's a nerdy 3 Fragezeichen expert in Paris? Okay, nobody. Okay, so actually they are fake. The other one were real, and these are fake photographs and actually photographs and transferred into 3 Fragezeichen style. And okay, this worked well. I would say this is probably production ready, solved, but it's in a way solved. But another thing I found while working on this project was basically everybody just likes to do cherry picking because of course I like to get applause for the PyParis comic or show you, okay, these are nice style transfers for the tiger here. But we should also see this because very often the style also like for something simple like style transfer, the style is not really learned and you get something out like this, which is not so presentable, but that's probably most of the stuff that comes out here. So it's not like a fully automatable process. Just send a picture, get a great style out, or train a great style on any picture. Applying works well, but yeah, not always. The models sometimes don't work on everything. So, and for example, this was also like a picture, and I had like a training set of like 30 pictures. I applied the styles to see how the style was developing while the model was being trained. So this was like a picture which hardly ever worked in any style, which is quite surprising because I thought, okay, this has like nice structure and it should work well actually, but it didn't. And then another thing with neural nets, okay, you also have to reason about it. Why is this not working? Yeah, what about the data sets? How are the data sets screwed? I had another example because like the 3 investigators, they are detectives. So what about a drug case? And I also saw something with like, I found some picture, I haven't it here, with like more like drug stuff. And it was also not really picking up. Yeah, so also like the data sets can be, the models are trained on, can be skewed. Okay, and another finding I have to point out here is looking at GitHub and Gits, and there's a lot of code shared on Jupyter notebooks, but I see like really nice libraries and they are released under the umbrella of a company like Facebook, and you find something there in Python 2.7. I said, what's going on? Is nobody aware Python will retire in a year and a month? So Python 2 will be gone then. So, so I think so. All projects for a while, all new projects should be really Python 3 now. So I was quite surprised to see this. Another thing is the code quality in Jupyter notebooks. I have to point out here. My PyRand. This is the PyRand slides here. So keywords are used as variables, like input or list, many closures. So closure is not a bad thing, but if you define a variable at the very top of your the Jupyter notebook and use it in a function at the bottom, I don't think this is good code style. This is not really readable and is not transportable, and it is something that should be solved better. Okay, this was like the summary as Nick Radcliffe speaking here about quantum computing. You see he's speaking at EuroPython about quantum computing, so he's a smart guy. He summed up my talk like this. He's English and I like his humor. So I have some updates because speech. So another part is how can I fabricate speech? And there is something new. So first fabricate speech and then make it sound like a known character. So there's a new neural net. It was released quite recently, or like at the beginning of the year. It's called Tacotron True. It's better than MaveNet. The basic idea here is to train on MEL spectrograms. MEL spectrograms are a representation of a sound. Like if I say, yeah, you can put it like in a MEL spectrogram, which is actually some Fourier transform, and then you can train the whole network. And if they align well, you can basically synthesize speaker, like somebody like your computer talking to you. So what do we need? We need audio snippets and text for the audio snippets. I was quite lucky to find a data set with 24 hours of recorded audio in the which was openly available, and I trained it, and I really will. I'll try to play it to you. I hope I can make it work with a microphone here. So the network was trained for 10 hours and then reading this text to you, and I hope you can listen to it. I don't think you can hear anything, yeah? Okay. Mm-hmm. So. Okay. Let me try again.
Why, it's a poem, is it? I've been a meeting named Sari.
No.
Although it's stuff of the facts.
So maybe the first row can hear something. So okay. Okay, I tried. Here at 10 hours, it's basically just like blibbering. I can put them. I can post it later online. Sorry, you have to have sound via HDMI here.
Use the mic, please.
Huh?
Use the mic, please.
Yeah, I tried, but it's not.
You have to speak when you're speaking.
Oh, when I'm speaking. Thanks. Okay. Thank you. Yeah, thank you. Okay, so here it was just like blubbering, like blah, 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 blah. You could recognize some rhythm, but here after 14 hours, you were also already able to hear some of the words. And this was, and after 5 days, like I'll try again with a microphone for the last time.
Once upon a time, there was a little mermaid named Siren who lived with her stepmother under the sea. He didn't get to go out of the sea like any other.
Okay, how did you like it in the first row? Okay, but here you can see, okay, this is still like a little noisy, but you can clearly understand the words, and after 9 days, I'll just describe it. It's already picking up, after 9 days, it's already picking up the comma here, and basically there was a little mermaid named Siren who lived. And this was quite impressive, because this is something I had not expected, because I think, this is audio is complicated, I'm not an audio engineer. It's the first time I really looked deeper into the whole audio space, and this was quite impressive, because this was just like built on a nice data set and trained for quite some time. So, next step. Of course, if you feed German to this does not work. So I need a German data set. So let's do this. I require audio snippets, text of the audio snippets, and all of this in German. And I did a lot of research online, and I was not really able to find any good audio set. Oh no, actually, yeah, find any set I could train. So we have to build it our own. So the task is cut audio snippets, have the text that's being spoken, with that, and options are audiobooks, or there are some newspapers with audios, but the requirement is actually humans to prepare the data set. So I talked to my business partner, Zir, and I said, Zir, can we hire 2 working students in our company, because I need to produce a German training set. And Zir said, Alex, I really like your talks, but no. So I had to come up with something. Smart. So, okay, so I came up with this. Let's take the news. I scraped the newspaper. There's an audio version of the newspaper article, which was read by a small set of professional speakers. And I have subscription for both, I have to point out. Then I fed the audio into a transcription service to get the words transcribed with the time index. And then having the time index and a lot of heuristics, I could produce an audio text snippet. So what were my expectations here? The transcription service will deliver very good quality, because this is what I read about all day, and especially from Google and every cloud provider. This transcription service is generally available and at all providers, and it should be cheap, and it should be also like it should be easy to generate this corpus. And this is what I learned for German, actually. The transcription service quality from Google I used, it's okay. Usually what's being said is being captured, but not word by word, which was quite surprising, because this is what I wanted a transcription service for. So still, the contents was basically captured, but not in the exact words. Transcription services are generally available. Yes, for the English language they are. Google was the only transcription service who is available for German. And I'm pretty sure it's the same for French and any other language not being English, or maybe Chinese, I don't know. So I looked, there's not at Azure, not at ABM, not at AWS. Apple is limited to iOS. So okay, this was something I was not expecting, because I made some false assumptions from, okay, yes, you read all about the great stuff happening, but it's mostly happening in the NLP space, thank you. In the English natural language processing space, because also like European researchers work in English because they want to publish internationally. So a little lag. Okay, back to the data set. So I had a data set of about 25 speakers, articles, texts scraped from the website. This was the setup, and it's unfortunately you won't hear it again. So let's play the reading. So I'm reading this. The speaker is reading this text here, and this is basically a very automatically generated data set here. So I'll try again.
Deutschland darf kein Talent vergeuden, so heißt es immer wieder. Wo aber bleiben in unseren Schulen die Angebote für die besonders Talentierten?
Okay, this was the original reader. Yeah, the original. This was not the network. But let's see, after like 14 hours of training, it's blubbering, like I'm trying to mimic it a bit. Okay, but after like 10 days, you can recognize the speaker, which was actually the data set was training on. And this was one learning here, because I had to classify who's actually speaking. Speaker derealization did not really work for me. I know why it did not work, but so I did some manual data labeling, and it was really late, and I had like 3 female voices in the data set in the beginning, and because of that, because like the female voices speak higher than the male speakers, the network was not really picking up under training. But then I limited it just like to 1 speaker, and then it basically started to work quite well. And this is basically trained for 14 days on maybe 12 hours of audio. Yeah, you can't hear it, but it's still not perfect, but still, given the resources used for this, I thought this is quite impressive. So if you want to have like your personal assistant speaking to you like your mother, just record her, transcribe her, and you can have like your personal assistant with your mother if you want, or your father, or Yeah. Okay. So the challenges here. So I had a lot of assumptions here, because like when I very first started, like neural networks are like scary. They are like super high tech. They are complicated math, and then algebra. And I'm not a mathematician. So let's go through them. So these were my assumptions. Neural networks are hard to set up. I couldn't really find it was hard to set because the knowledge about them is freely accessible, and many people put a lot of content and open source notebooks there. There was a lot of useful stuff and also like well-coded stuff. For example, the Takoton Drew I built on from a Git from NVIDIA, which was really well coded. It was really beautiful code to read, also from the parameterization and everything. So neural networks are hard to train. No, they're not. Even like the parameters, you can try, and there's also libraries helping you how you can tune and optimize the parameters you feed when you train your network. Neural networks are smart. Let me give you some examples. Who uses Google Translate? Okay. Who has ever used Google Translate for Somali? So there's some people who put like 25 times "ak" in Somali, and this is the translation in English. So 20 times "ak" in Somali, Google says, as a result, the total number of the members of the tribe of the sons of Gershon was 150,000. So this is, and actually it's "ak" sounds more like Irish, like to Google. But this is, I think, although this is like super funny, this is a very good example how what neural networks actually are. They are super highly specialized idiots. And yeah, but if you read them, and it's just like very complex correlations going on there. And if you find some crazy stuff like here, you can hack the network, say something like this. So they're also not perfect. And I think this is also something we have to basically adapt to as a human, because machines have to be perfect. Like usually that's what we're used to. Machines have to be perfect. Obviously neural networks are very good at specialist tasks, but also probably not perfect. Also, another thing is, this was, I thought was like, if you know, who knows the MNIST model? Yeah, the MNIST, yeah, okay. The MNIST model, for this, you know, the MNIST model is often used in introductory trainings. Have a neural network train to read handwritten numbers. And Emilio Dupont, actually, he was, as a full blog post, he just used this and put a chicken in this set. And the neural network was 99.9% confident the chicken is a 5. And this is also like really funny. It's a really nice finding. And so you see like neural networks never say, oh no, I don't understand this. This is probably not a number at all. And this is, another thing, also it's a challenge in the image space, but probably also like for autonomous automotive. So here you see a picture of a panda. The network is 57.7% confident this is a panda. And then we put pink noise in here. And then the neural network with the same picture for our human eyes is 99.3% this is a gibbon. So another thing is neural networks, and this is something which is very often a misperception in the public, they are not working like humans do. The whole technology is heavily inspired by how our brain works, how we work as humans, but it's linear algebra, it's math, it's with impressive results, but stuff like that, it's confusing, but it's also very entertaining as well. So another thing is also like a nice pointer to read is data is the new oil, because I'm being also like a consultant, I'm really sick of hearing about this, because actually it's very wrong. It's more like nuclear power, because oil is limited. We don't know until when, so but data is unlimited. So, and we should not think of data as an oil, because once we have this picture in our clients' heads, it's oil. You can use oil and basically make everything out of it. This is what I see with many C-level customers as well. They say, oh yeah, we have data, and what can you make out of it? Yeah, sorry, your data is like, it's not well maintained, it's not labeled, it's probably unusable. We first have to think about how to record your data properly. Managing also like the resources required, because this was like, okay, I have the data anyway. Oh, thank you. Okay, the data anyway, the big the AI, the network, the everything that will be a big problem, and then running the models will be also like a big problem. But the reality looks more like this. Data engineering takes way more time and making like a nice data set and also like the updates and everything. The network wasn't a big problem at all because other people have already solved this. So yeah, there's many people in open research who share the networks they develop and share the networks they work. So of course there's a lot of there's a lot of effort in here, but it's not our concern basically. Our only concern is to say thank you to the people who share the stuff. Yeah, and running the models is also like not as easy here. If you want to go a little deeper here, this is a nice picture how to put this in production, like with the data cleansing and also updating and the feature engineering and the models and stuff, but I don't want to go, I'm a little bit late on here. So a very good read is this 3-part blog post from Rachel Thomas. She works for Fast AI, and it's a nice write-up what machine learner practitioners actually do beyond the hype and the magic people expect. Because I heard about companies buying a Hadoop cluster, buying Watson, and then hiring the first data scientists. And this is the reality out there as well. It's not wrong, because before you bought a machine and then people to operate it, but this is not how data and data science and everything like this works. The singularity is common. I don't know how popular this is in France. Who has heard about this from Ray Kurzweil? The singularity is coming. Artificial intelligence will totally supersede human intelligence in a few years. And yeah, it's also like, it's a nice, it's an interview from the German Zeitmagazin with Margaret Bowden. Margaret Bowden has worked for Neuronets for more than 40 years. And she just says, yeah, okay, she doesn't believe it, and you think like, is Kurzweil like a spinner? Which is, didn't know that is an English word actually, it's German. And he said, yeah, he's a genius, but he's very wrong here. So this is also like, yeah, nice read. Unfortunately only in German available. But a problem also for us is the marketing bingo. These are like the pictures which we often see with artificial intelligence. It's a human reasoning, like Shakespeare-y Hamlet style here, or a robot reasoning about formulas, like a professor. And this is like something, this is very wrong. And this was something I really had to think, because I don't like to complain on Twitter. I'm not of these guys. But I saw this marketing tweet from Siemens. So let me introduce you to Uli. Uli works in Munich at the Viktualienmarkt, which is a really fancy address, with his colleagues, and he teaches robots how to think. This is the translation of the things. And I couldn't really help it to say, machines don't think. Maybe Uli wants to explain this to your colleagues in marketing. And actually Uli replied, yes. And Uli said, yes, yeah, you're right. Yeah, we do software. And this is like the misperception you see, like HR and Siemens is already saying, oh yeah, he's a machine thinking teacher, like how to teach machines how to think, but it's not even his own self-perception. So, and this is leading the wrong directions. So to basically look into the next steps, because there will be version 3, 4, 5, whatever. These are the next things I want to look into it. Look into story generation, which feels easy. It's just like a children's detective story, but my first research says, okay, it's probably not. Training a better model for German, like sounding like text, improving the speech synthesis. I think with a clearer data set and more data, the German speech synthesis can be done better. Also applying, giving characteristics of one of the characters, which is also possible, should be possible, and also like auto-selection of good models. So have some system set up which basically can decide this model is actually, this will work well, or you can train this forever and it's unlikely it will improve that much. The same for pre-tuning of data, for example, with the pictures. Sometimes the pictures for style transfer, if you mangle a little bit with the pictures, the results on the style transfer are also like different and can be also optimized. And also, for example, yeah, so having like scene agnostic style transfers. This is something, look it up. So of course, neural networks are super useful. I think we just need some better pictures. So I think it's already quite gracious if you say, okay, let's rather look them as ants and then as human-like robots. And yeah, thank you very much. That's it.
Thank you. All right, time for questions. We have 5 minutes for questions or comments. I have one question. Yeah. What other things of another question? You mentioned the importance of doing research with neural networks or experimentation that's reproducible, so that you can go back in the past and check what was working, add some new tweaks. Do you have some practical advice for this? Because it's not so easy to be well organized. I know you're German, so it's easier for you than for the French or Italians, but how do you do that?
No, basically, and I share another fun fact, that TGV is way more punctual than the German trains, so... So no, yeah, actually it is. I built something myself, just putting the parameters to a JSON file and actually copying pictures I was working on or text over. Of course, this is a lot of redundant data, but it's really nice because I can also just transport it off to some external drive to put it in the shelf somewhere if my computer is overloaded. There's also libraries for that. I think Cookie Cutter can do it to set up like a base, also like a data science lab for having everything in place there. Yeah. So, but I haven't found the perfect library for that. And it didn't look so hard as well because yeah. I just built something myself, just take all the parameters in and write them to a text file. Yeah.
All right, thank you. Is there another question? Yes.
So you mentioned earlier the stability problem. So the fact that you can basically trick an AI into thinking a picture means something else. I was just wondering, do you have any insight as the progress on this particular problem and how we can kind of improve on it?
You think when the model starts to be stable?
Yeah, I was referring to the panda picture that you can make it think it's a car or whatever.
Ah, okay. It's basically we can measure it just by comparing with test sets, but it's not probably that's the best I could come up with actually. Yeah, so it's but here it was this is still a little bit also on my bucket list to solve. But this is what I want to use. But also we have to, because it's neural networks, it's deep learning, and as many people have pointed out at many conferences this year, like Gail or Vincent van Dam, is neural networks, with deep learning, you still have to think, because this is very often forgotten. Many people, if they come from university, they say, okay, let's solve this problem with deep learning, and not even consider thinking. And actually thinking is very important, because also if you think about which spaces worked well and which spaces didn't work well. So, for example, the text. Text is very well defined. I can tell you, okay, this is a good German text, this is bad grammar, these are real German words or are not. If we look into the art and the picture space, this is not defined. This is open. We can just say, okay, this looks like, or this is appealing, and this is comparable, but it's harder to it's harder to measure, but also the target space is way opener than on text, for example. And the same for a human voice. A human voice is yeah, we know, is it a human or is it not? Yeah.
All right, if I can add something about making neural networks more robust against this kind of noise. There is a lot of research on this, and one idea that people had was the following. The thing is that these things work. I mean, you can really fool the network, because there are some pixels that you just, for each pixel you can see its impact on the result, and you just find the pixels that have the most impact. So there were these guys who had the idea of making the impact of changing 1 pixel 0 almost. You can look into thermometer encoding. That's the idea. So instead of basically having the input be kind of linear with respect to itself, you can change the input, and there is a first output layer that won't change even if you change the value of a pixel, basically. So thermometer encoding, you can look into this. You will have more references there. All right, 12:45. We're on time for lunch. All right, so everything will resume at 2, and thank you, Alex, again.
Thank you, and thanks for the computer.